Okay, so we've got some excellent stuff happening here because we have created objects and methods. Now we can make decisions, and we can make decisions in multiple ways and create multiple paths in code. If, nested ifs, if else if, switch statements. I showed you a couple of ways that you can throw methods in there to call a method based on a switch statement. So there's actually a lot of stuff here that if you get really creative, you can start creating some interesting things. Now, I want to introduce two things in this video. I want you to follow along with me. Hopefully it won't be too much material in one video to cover, and I'll try to be swift with it. We have been basically generating our own data. We have been creating variables, declaring the type, creating a variable, assigning a variable, and all of that's been hard-coded into our programs. The only issue with that is usable functional programs also have input as well. That input may be from a database, that input may be from a file, that input may be from a user interface, but you're interacting with something. If not a person, another program. And the paradigm for both of those is actually the same. You're receiving data in from some source and doing something with it. So what we're going to do is I'm going to show you how to read in values from the console, and then we're going to translate that over into iterating. That is looping through something. So we've talked about classes, and now classes, it's called expose methods. Classes have methods that allow us to do things. We've been using them. Console.writeLine, console.write, console.readKey. You've actually been receiving input but not doing anything interesting with it. Console.readKey actually waits for you to hit a key. So it's just sitting here waiting. You hit a key and then it exits. So it did what it was supposed to do. Now, we didn't assign a value with the read key, but we could actually catch that value and do something with it. So let's look at IntelliSense and teach you a code technique, or the way to go fishing for classes, or for methods inside of classes. And we see ReadLine and write, but we don't want to write. We want to read values in. So let's look at read. We've got read, read key, and read line. So we're going to actually start reading a line. Read line. What this does, it does some interesting, has some interesting behavior. But let's think about the console class being a single class that controls input and output. So when we do console.writeLine, it pushes output to the console. When we do console.readLine, it's reading a line in from the console. So we want to read a line in and do something with that information. One of the interesting twists to it, is when you read a line in, you read a line of text in. So if I put string line equals console.readLine, it's not an issue. But let's say I want to read a number in. So I do int value console.readLine. Well, we got a problem here because we are reading in text data, and we've talked about data types, and that's why I wanted to talk about ReadLine and reading data in later on after we had discussed some of these topics. So int is a data type, string is a data type. It represents the values that a data type represents. It's the star hole, it's the square hole, it's the circle hole to put certain types into. Well, some of those types actually cross over. That is, you could represent a number as a string, number equals 6, or int number also equals 6. Now, behind the scenes, both of those are represented differently. The string is represented by a number that represents a string. It's an ASCII or Unicode, which are encodings. That is, a number backs it. So the value at the machine level, at the 1s and 0 levels, is actually not a 6. The value at the machine level is some other number that's been designated to represent 6 as text. I know that's a lot to wrap your head around, but 5 as a number is represented as 5. But 5 as a string is not 5 anymore. It's a character, because you have to be able to distinguish the difference between 6 as text and 6 as a number. So we receive text in. So we say, well, how do we get data in? What are we going to do then? You had this ability to cast or convert a value from one type to another. So if we know that that value that's coming in is going to be a number, we can use another class, convert class. It's a helper class, and we're changing the value, and we're changing it to int32, and we're converting it. So we're telling the compiler, we're saying, hey, listen, I know you're reading text in. I know you're getting prepared to read text in, but we know that that text that we expect can be converted into a number, and we're going to catch it with a number. We're going to catch that in as a number. Now we've opened ourselves up to an issue, because if we expect a number and we get text, we can have an error. So let me show you what I mean. So console.WriteLine. Okay, so actually right now our console is waiting for us to enter something. So I'm going to enter 5. It echoes 5 back to me because we did console WriteLine.value. Now, we're casting this value that's coming in, this read line text, into a number. Well, what if a number doesn't come in? What if I just type my name, Isaac? Oh, we got an error. And it says input string was not in a correct format. And what it's saying is, you told me that you were going to give me a number when you assigned it to value, but you gave me text. So there are some things when you're reading in data from a user, from a console, from the input, you need to, you can put a prompt and say, please enter a number, and there are ways to catch it and say, oh, if you entered text and you should have entered a number, we can code against that and protect against that. But I wanted to show you that there are issues with data input that you have to prepare yourself for and defend against when receiving values or data in. Because if this had just been a string word equals console dot read line, and I change this to write them out, I'm going to enter a 6, I'm going to enter my name, and it echoed back 6 in my name. See, now, this should let you know that there's some things going on behind the scenes. So you say, okay, Isaac, if everything that's displayed on the console is text, when we write line out, when we write an integer out, what's happening? What is happening is console.WriteLine knows how to receive an integer value, and then it converts it to what it needs to be converted into when it pushes it out to the console. So it has the logic behind the scenes to be flexible to do those things for you. So now, we can actually read data in. Let's say that we can read data in, and we want to do code X number of times. So let's say integer iterate equals convert dot toInt32 console dot read line. Now, we're going to get from the user, let's write out a prompt, console.WriteLine. Let's tell them what we want to do. Let's say, please enter the number of times to say hello. And then when we run this, it's going to say, please enter the number of times to say hello. And you've got the cursor prompting you to tell it how many times to say hello. Let's say 5. Excellent. So now we actually have to write the logic out to say hello 5 times. There are multiple types of iteration statements. An iteration means it's going through and doing something X number of times. It's iterating. We're going to start out with a for loop. Now it's got a funny syntax, but for, and just like we had with the if statements and the switch statements, and using in method parameters, we have these pair of parentheses that we're going to pass something in, and we've got logic contained within the parentheses. We're going to declare an iteration variable. So you've done that before. This is a statement. We're going to declare, and it lives only in the code that we're executing for the for statement within the braces that come after it. We're going to say how many times that we want to do something. So we're getting that from the user, iterate. So as long as I is less than iterate, so think about the conditionals, the if-else. This is a conditional. As long as I is less than iterate, and this is a shorthand to say add 1. I++ says add 1 to I. Okay? It's 3 statements. Initializing a variable, checking the condition, and you see the semicolon separate them, and then adding 1 to I each time. So what's going to happen is we're going to write console.WriteLine hello. And what's going to happen is so when we were going through the if statements and branching off if, else if, we're going to fall into these braces, this code section right here, console.WriteLine hello, and we're going to go through it once. We're going to add 1 to it. We're going to check it. Twice. We're going to add 1 to it. We're going to check it. And as long as this number, or I, our counter variable that we declared here, is less than whatever we specified here, it's going to write out hello that many times. So let's try this again. Print the number of times. Please enter the number of times to say hello. 5. Hello, 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 hello. You printed it 5 times. Now here's the interesting thing. If you followed along and you've written this, is we've actually now given the user control over our program. Because if I enter 3 times. If I enter 7, print hello 7 times. Now we've made a big leap here. We've made a big leap in several different ways. Not only receiving input, but actually controlling our program from an external source, using an outside source to control how our program works. And we've done that with a for statement and receiving data in from the user. So there's a lot packed into this, and if you have to go over this stuff multiple times, that's okay. But because this syntax is very different, and it's nothing new, because you know how to initialize variables, you know how to check conditions, and you just learned how to iterate by 1, which is or add 1. I'm sorry, increment by 1. But it's a really tight syntax right here if you're new to it. And what you've got to think in your head is, I'll show you. We'll get rid of this code right here, and we'll say we're going to iterate it 5 times, or less, as long as I is less than 5. And we're going to write out I. And I want to show you. And we're going to debug through this. So let's run it. So it says set I equal to 0. I is less than 5. Let's execute. We're going to get 0 out in the console. See? Now we're going to increment I by 1. Check it again. Is I less than 5? Yes. Execute. 0, 1. so on and so forth until at I, if we see down here, we've got a locals window open. I is equal to 5, so it's no longer less than 5. So it bounces out, it drops out of these braces, and gives the user a chance to read the key, and we've said 0, 1, 2, 3, and 4. So that is the magic of a for loop. There are other iteration loops that we're going to go over in the next couple of videos, but now you've got all of the tools to really start building flexible programs, because you can receive data you can receive input from the user, you can control your program with that input, and then you can actually iterate over things and do things multiple times. So you can make decisions, you can set your algorithm sequence up, and then you can also do things multiple times in a very tight syntax. So take some time to digest that, and we'll go into the other types of variables, or other types of loops that you have available in your programmer's toolbox with C#.